This is a demonstration of the Seismic Design Group Seismic Bracing Calculation Program. The program consists of 5 input steps and concludes with a comprehensive 3-page calculation report that can be viewed, printed, and/or saved. In Step 1, the project description and report prepared by information is entered. Each step of the program has a help button for that step and additional buttons for useful information. When the Go to Step 2 button is clicked, the information entered in Step 1 is saved and will not have to be re-entered for each calculation, unless the user chooses to do so. Each step of this program has numbered items to be completed before going on to the next step. These items are shaded in green. If the Go to Step 3 button is clicked and the items have not been correctly completed, an error message is displayed and the shading for the incorrect item number changes to red. As these items are corrected, the shading changes back to green. This error-catching technique can be seen by clicking on the Go to Step 3 button before any of the items have been completed, and then fixing them. Item 1 requires the user to input the S sub S and S sub 1 values for the project from the seismic activity maps. If you already know these values, enter them here. For our friends in Puerto Rico, we have a convenient drop-down menu from which the municipality can be selected and the S sub S and S sub 1 values required by the Puerto Rico amendments to the 2009 IBC are automatically entered. Use of the maps in the building codes to access the S sub S and the S sub 1 values is imprecise. However, this program has a useful tool to access the USGS S sub S and S sub 1 values using their calculators, which use the same data points that were used to draw the maps in the codes. Click Get S sub S and S sub 1 to access this tool. This tool has a link to a GPS locator to acquire the accurate latitude and longitude for use with the USGS calculator. First click Get GPS and enter the address of the project. Second, click Go USGS and resize the windows so that they can both be seen, and follow the instructions to get the S sub S and S sub 1 values. The newest way to get the S sub S and S sub 1 values is to use the USGS Worldwide Seismic Design Maps web application. To access this application, click USGS Global. After registering your email address, click Launch Application. At the security warning, click No. Click Enter Street Address and then enter the street address of the project into the text box. The S sub S and S sub 1 values will appear. Use the values for the 2009 IBC. Restore down the USGS site and close the Get S sub S and S sub 1 tool. Now enter the values into the Step 2 text boxes and close the USGS calculator. Note that if the Go to Step 3 button is clicked before completing the other items, the incomplete items change from green to red. Select the site class in Item 2 and the occupancy category in Item 3. Now, when the Go to Step 3 button is clicked, the items will be changed back to green and Step 3 will appear. Item 1 of Step 3 is used to select the type of component being braced. The primary selection possibilities are piping systems, ductwork, electrical conduit, bus duct, and cable tray, mechanical and electrical equipment, vibration-isolated components, and manufacturing or process conveyors. Some of these selections have subcategories such as trapeze-supported or vibration-isolated. In this example, we will select piping systems and calculate a 4-way sway brace per pipe on a trapeze hanger. The trapeze selection will be made when the button is clicked to go to Step 4. Item 2 of Step 3 is used to select the component importance factor. In this example, we will select an IP of 1.0. Item 3 of Step 3 is used to select the component anchorage elevation in the building. In this example, we will select the top 1/3 of the building. With these selections made, we can click on Go to Step 4. This will open the window where we will click on the button to go to Other Piping Trapeze Supported. Item 1 of Step 4 is used to select the pipe description. In this example, we will select non-ASME pipe with joints made by threading or groove couplings. Items 2, 3, and 4 are used to select size, type, and quantity of pipes on the trapeze. Up to 6 different pipe sizes with descriptions can be selected. Any quantity of each of them can be entered. In this example, we will select Pipe 1, 1 1/4 pipe, uninsulated Schedule 40 with a quantity of 3. Pipe 2, 2-inch pipe, insulated Schedule 40 with a quantity of 2. Pipe 3, 4-inch uninsulated Schedule 40 pipe with a quantity of 2. Item 5 is used to calculate the weight of the water-filled piping on the trapeze. Click the button to calculate the weight of the water-filled pipe. Then click the button to go to Step 5. Step 1 of Step 5 is used to select the ID number for this calculation, which can then be referenced on shop drawings if desired. For this example, we will simply enter 1 for the ID number. Item 2 of Step 5 is used to select the sway brace orientation. In this example, we will select 4-way. Item 3 of Step 5 is used to enter the maximum sway brace spacing. In this example, we will enter 40 feet. Item 4 of Step 5 is used to enter the hanger rod size for use in the rod stiffener calculation. In this example, we will select 1/2-inch rod. Item 5 of Step 5 is used to select the structure for anchorage, which can have subcategories for some anchorage types. In this example, we will select 3,000 psi lightweight concrete on metal deck with the no pry clip and Powers SD2 anchor for the subcategories. Item 6 of Step 5 is used to select the fastener orientation. There are 3 fastener orientations, and the fastener image changes when this selection is made. However, since we selected 3,000 psi lightweight concrete on metal deck, the only possibility is orientation 2, so orientations 1 and 3 do not appear. Item 7 is used to select the brace angle from vertical. In this example, we will select the range from 45 to 59 degrees. Item 8 is used to select or enter the thickness of the structural element that is available for anchorage. In this example, we will enter 6 1/4 inch concrete thickness. Item 9 is used to calculate the required brace. Click the button to calculate the required brace. Item 10 is used to view the completed calculation report. The report can be printed and/or saved from this viewer. Click the View Report button. The report consists of 3 pages. The first page shows the project and calculation prepared by information. The calculation of the seismic design category, and the calculation of the allowable horizontal load factor. Page 2 shows a brief description of the sway brace calculation, followed by the calculation of the sway brace zone of influence, followed by the calculation of the horizontal earthquake load, then the calculation of the required seismic wire rope cable brace size, and finally the calculation of the allowable horizontal load carrying capacity of the fastener for anchorage. Page 3 shows the calculation of the net upward vertical load, followed by the calculation of the maximum hanger rod length and/or rod stiffener clip spacing. The applicable sway brace model for this calculation, along with any other notes that may have been added in Step 5, appear in the box at the bottom of the page. The report can be printed to any system printer. We recommend printing to a PDF distiller so that the calculations can be saved to a project folder and printed as needed. In conclusion, this program can be used to prepare comprehensive code-compliant seismic sway brace calculations in minutes for all suspended non-structural building components using sway brace angles from 30 degrees to 90 degrees from vertical. The speed of this program also makes it useful for very accurate job estimating, and, even though it is intended for sway brace calculation, it can also be used to simply calculate the horizontal load factor for floor, roof, and wall-mounted equipment by just using the first page of the report. This seismic sway brace calculation program is available in versions complying with the requirements of the 2005 and 2010 editions of ASCE 7, including the 2006, 2009, and 2012 editions of the International Building Code, the NEHRP or FEMA standard, the Unified Facilities Guide specification, and NFPA 13. For additional information or to get your 7-day free trial of the fully functional program, please contact a Seismic Design Group representative.